Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to do some more trig integration. So we're going to evaluate the trig integral from 0 to power over 2. We got sine to the fifth of x dx. So the first thing that you want to do here is just rewrite our integrand a little bit. So I'm just going to rewrite this as the integral from 0 to power over 2. I'm going to write this as sine to the fourth of x multiplied by sine of x, and then dx. And if I continue to rewrite this, I could then write this as the integral from 0 to power over 2, and I can just write this as sine squared of x quantity squared multiplied by sine of x dx. And then from there I can also rewrite sine squared of x using a trig identity. So remember that sine squared of x, that's just going to be 1 minus cosine squared of x, because remember the Pythagorean identity that sine squared of theta plus cosine squared of theta is equal to 1, or cosine squared of theta plus sine squared of theta is equal to 1. In this particular case it would be x. So all I did is use the following identity. So sine squared of x plus cosine squared of x is equal to 1. If I solve this equation for sine squared of x, I'll get sine squared of x is equal to 1 minus cosine squared of x. So if you're wondering where that came from, that's where it came from. And so now what we've done is we've put ourselves in a position where we can now use a substitution. Let's let u equal cosine of x, because we have that sine of x hanging around on the outside there. Now when we differentiate, we will have a negative that we'll have to move to the front, but no big deal. We'll be canceling out the sine. That's all that really matters. And so when we solve for dx, this is what we end up getting, and it's going to help us cancel out the sine. So the sine's going to cancel. I'm going to have to change the limits, but I'm going to bring the negative to the front. And then what we'll end up having is 1 minus u squared quantity squared, and then it's going to be integrated with respect to u. Now what I would do is go ahead and expand out the inside here. And when I say expand, I'm talking about the 1 minus u squared quantity squared. Keep in mind that's really nothing more than 1 minus u squared times 1 minus u squared, at which point you could just FOIL it. And if you end up doing that, you'll just end up with 1 minus 2u squared plus u to the fourth. So the integral would then be the integral, and then it would just be 1 minus 2u squared plus u to the fourth du. You can distribute it in the negative, and if you do that, then you'll have integral, and it'll be negative 1 plus 2u squared minus u to the fourth, and then this could be integrated with respect to u. Now I need to change the limits, so we can change the limits of integration. So we'll go and remember that u is cosine of x, so we don't need to change them. So this would be cosine of 0, which we know is 1, and then cosine of pi over 2. Remember that's just 0. So what I would have to do, since I would end up with 1 as the lower limit and 0 as the upper, I could flip the limits of integration or swap them, but I do have to change the sign of the integral to do that. So I'll go to a different sheet. So if I do that, I'll then just have negative, and then I'll have the integral from 0 to 1, and what I'll have is negative 1 plus 2u squared minus u to the fourth, and then this will be du. So if we integrate from 0 to 1, we'll see what we get. So the integral from 0 to 1, negative 1 du. From 0 to 1, that's just going to be minus 1. And then the integral from 0 to 1, we got 2u squared. Well, the 2 would be on the outside, so that's a constant. That'd be u to the third over 3 from 0 to 1. That'll end up being 2/3, so this would be plus 2/3. And then over here, this will end up being minus 1 over 5, because we would apply the power rule. That'll give us u to the 5th over 5 from 0 to 1, which would give us 1/5, but there is a minus there. And so if we simplify here, we do have this negative on the outside. Let's be careful. And then we'll get a calculator here to check the arithmetic, and we'll see what we get. So it looks like we're going to end up getting 8 over 15, which will be your answer. So this would be 8 over 15 when we simplify it. So your final answer for this trig integral is going to be 8 over 15. So we're asked to evaluate the integral from 0 to power over 2, and it was sine to the 5th of x dx. So the answer to this would just be 8 over 15. And that's the solution. Alright, so let me circle that for you. Now, if you have any questions about how I arrived at my answer, I'll be more than happy to help you with that and explain it further. Alright, so that's going to be it, guys. We'll see you next time. Y'all take care.